looking at number 1. So it says, look at the circle graphs. And so you have 3 circle graphs. This is also stuff that you saw in your interactivities for science. And it says, write the letters of the correct answers on the lines at the left. So it says, what evidence supports the importance of the ocean in the water cycle? So it says the ocean represents about 97% of Earth's water. The ocean provides most of the fresh water that people use. The ocean is saline, so it contributes dissolved salts to the water cycle. Or the ocean is not important to the water cycle because it is salt water. So you're using those circle graphs. What's the correct response there? Anybody? Nobody? Riley? Might have to raise your hand a little higher.
I want to say C.
Okay. Why C?
Because D is wrong. E can be right, but we're not completely sure. And then A can also be right. But C is the one that kind of tells us.
Okay. What do you guys think? I have a thumbs up. I have lots of crickets. Is that what the graphs tell us up there? Because it says use those graphs, doesn't it? So what does the graph tell us up there?
Like how much water is on Earth?
How much, yes. So it's telling me quantities, right? How much of Earth's water is ocean water? Ellie?
97%.
97%. And we wrote that in our Cornell notes. At least twice. Right? So the correct answer is actually A. Correct answer is actually A.
That's what I just put it in there.
Mm-hmm. You have to pay attention to what the question is asking as well. Okay, so then the next question asks, number 2, says which 2 statements, so there's going to be 2 correct answers, about Earth's fresh water are supported by the graphs. Once again, going back to the graphs. So you have A, most fresh water is in glaciers and ice caps. B, aquifers are the largest source of surface water. Now I've got to flip over. C, only a very small amount of available water is fresh water. And D, salt water represents only a small portion of available water. So 2 of those say small portion of available water. And then you have aquifers are the largest source. And then you have most fresh water is in glaciers and etc. So which ones are the most accurate answers judging by the graphs? Jalen?
A and C.
A and C are the correct answers. Okay, so moving to number 3. Flip it over here, sorry. Number 3. Blink. Number 3, it says, based on the circle graphs, which is the largest source of surface drinking water? Largest source of surface drinking water. Lakes, oceans, aquifers, or wetlands? Largest source. Based on the circle graphs, what's the largest source of surface water? Drinking water, I should say. Levi Adams.
Glaciers and ice caps.
Okay, but on number 3 we have lakes, oceans, aquifers, wetlands. Marky? It is A, lakes, something that we also wrote down in our Cornell notes. It was a picture in our textbook too, in our e-text. Okay, number 4. What provides the energy to power the water cycle? I'll give you a hint. It is the energy. It's what powers everything. Kirsten. The sun. A. Very good. All right. Number 5, it says sort the steps of the water cycle into the correct order. Number them starting with runoff as number 1. Well, I already gave you one correct answer, right? Runoff is number 1, so we put a 1 by runoff. After runoff, This is where it pools into lakes and streams and things like that. What happens after that? What's the second thing that happens? This was also in an interactivity. Riley, what happens?
Evaporation.
Evaporation is number 2. After evaporation, what happens? Marky? No? No? Levi Adams?
Condensation.
Condensation, that's what creates our clouds. And it's not until our clouds are created and get too heavy, and then the fourth thing is precipitation. Okay? So the next one says, use the information below to answer questions 6 and 7. This has to do with the virtual lab that you guys did. It had the ability to redo as well. Okay? It's the steps of the investigation, so I'm not going to go over that one with you because you guys did have the opportunity to see that one twice. Okay? So you guys need to look at that very closely. Alright, so it says Tyler's, whoops, can't see it. Tyler's observations are shown in the drawing. He's got 1, 2, 3, 4, and this is an experiment. It says write the letters of the correct answers on the lines at the left. It says number 6, which is the best label for the process labeled 2 in the drawing? Is that collection, evaporation, precipitation, or condensation? Levi?
Condensation.
It is condensation. If you listen to anything Ms. Lewis just said, you would know that. Number 7, why does Tyler need to use boiling water in the investigation? What does boiling water do?
It bubbles.
It bubbles, yes. But what comes off the top of it, Marky? It does. It causes the water to turn into vapor. So B. Okay. Number 8, which is the correct title for this diagram? We gotta look at the diagram here. Correct title. Number 8, correct title. So you're looking at the picture. So is that a glacier? Is that an aquifer? Is that permafrost? Is that salt water? So look at it. It's underground, and then it comes up out of the ground. Levi Adams. It's an aquifer, B. Underground aquifer. Would you guys grab that door for me, please? Thank you, Kirsten. Okay, number 9. Which 2 solutions, so 2 correct answers, which 2 solutions address the lack of human access to clean water? Which 2 solutions? Reducing usage, melting glaciers, digging aquifers, digging canals in the wetlands. What are the 2 that are most reasonable to address the lack of human access to clean water? This was also an interactivity. Marky? Okay, that is one of them. I need the other one. Levi Adams?
Melting glaciers.
No, melting glaciers actually isn't one. How are you going to get the glacier to be melted? I don't know how you're going to carry it. You did a whole interactivity over this. Riley?
Digging aquifers.
He already said that. Jalen? Reducing usage is the other one. So A and C. Okay, a city has limited access to freshwater resources, so the city builds this structure. What is that structure? It's kind of hard to tell by the picture a little bit. What is that structure? Can anybody identify it? Riley? No, I asked, that's not the question I asked. I asked, what is this structure? Levi Adams.
Like a dam that cleans water on the inside?
It's a dam. It actually doesn't clean water on the inside. What is it doing? What does a dam do? What's the whole purpose of a dam? It stops the water, right? All of the lakes around here, They are created because of a dam, okay? So it collects and stores water. So number 11 is which diagram shows the importance of oceans in the water. So if you'll notice, this one is A, this one is B. Doesn't look like anything we've seen to this point. Just saying. Turn my page with my left hand. This one is C, and this one is D. So we're talking about oceans' impact on the water cycle. Once again, that was an interactivity. I'm not going to do that one with you guys. You should be able to get that one. Number 12. And remember, number 11 does have to do with quantity. Nothing else really. Quantity. Okay, number 12, which two features most greatly influence the temperature of the ocean? Two things. These are in your Cornell notes. I know they are because I wrote them with you. This was the set that I wrote. Okay? So I think you guys can go back to your Cornell notes on that one. I really, really do. Number 13, I think you can do. And number 14 and 15 are reading a graph. Okay? So, there we go. Make sure that you guys go through the rest of those, and it is time to start packing up. Now, remember your procedures, please. Remembering procedures.